Using Docker Swarm, we created a virtual cluster in the MLG IRIDIA cluster that allows to run a distributed streaming application using Kafka, Spark Streaming, and Cassandra. So the setup is as follows, and all the details are in the wiki at this address. So basically we have the MLG IRIDIA cluster with 10 nodes, and the swarm was installed on 3 of them, from slave 08 to slave 10. In more detail, here are how the components are distributed in the swarm. So we have a Cassandra ring of 3 nodes running on slave 08 to slave 10. We have a Spark standalone cluster with the manager running on slave 08 and 2 workers running on slave 9 and 10. The Kafka container running on slave 08. And finally, a container that has an SSH service that will allow users to connect to the cluster, the virtual cluster, in a way very similar to how we connect to the cluster. So usually connection is made with the user 1 node using an SSH connection and some port forwarding. And here is going to be the same, using a redirection to the SSH container. So when we connect to the cluster, we'll redirect port 23 of slave 08, which is the entry point here to the swarm cluster. And we'll be able to connect to that entry point using an SSH connection locally, and for the moment, the only user in the swarm is guest. So let's do this. First connect to the Hadoop cluster. So we have 2 redirections, slave 08 23, which will be locally available at 4423, and the port 8080, which is the Spark user interface for the standalone cluster manager here. Let's get connected, and so now, if I go locally to port 4480, so which is port 8080 on slave 08, we have the Spark cluster manager user interface. And we see that we have a Spark cluster with 8 cores and 8 GB of RAM on 2 nodes, each with 4 cores and 4 GB. So these 2 nodes are slave 09 and slave 10 here on the 2 Spark workers. Now that I have the redirection of slave 08 23 locally, I can connect here locally on port 4423. So this is the SSH port for the Docker Swarm. And then I have 2 redirections, 4040, which is the Spark user interface, and 8888, which is for the notebook. And I connect at guest and locally, and that will go to slave 08 23. The password is guest. And so now I'm in the SSH container that contains the notebook, Jupyter Notebook, and that allows me to get access to all the services in the Docker Swarm. I have a script called setenv.sh, which basically sets environment variables to use a Spark and Python and Java. So let's first execute this. And then I can start the notebook with the notebook command, so which is an alias to hear this command. And now the notebook runs locally in the container running in the Docker Swarm at port 8888, which I can access here thanks to my SSH redirection at port 4488. In the local directory, I have 2 notebooks here for the demo. So we have one which will send data to Kafka, and another one that will receive them, and then through Spark streaming, store the data in the Cassandra database. So let's execute the different cells of the notebook. First, we connect to the master node, which is at the address Spark master 777. So this is a cluster manager in the Docker Swarm. And we set the Cassandra connection to Cassandra seed, which is the host name where the Cassandra seed node is running. Then we'll have a function to store data to Cassandra. Then we have the streaming task that will receive the data from the Kafka node and will write them to Cassandra. And we can start the streaming. Then on the producing side, we'll simply send messages that are timestamps of when the messages are created, basically. And this in a loop. So now we can connect to the Spark user interface, which is by redirection available on port 4440. And here we see that the job is running now. So we have about 4,000 messages which are received per second. So that's here, this loop is able to send up to 4,000 messages per second. And here we see that the processing time for this is about 1 second for each batch of 5 seconds. So which contain about 4,000 messages per second times 5 seconds, so around 20,000 messages. If we go in the stages part here, so this is an example of stage where data is received. And we can have a look at how this is distributed. And so we see that we have, so one core is used for the streaming application, and there are 7 remaining cores to process the data, and we see that 3 of them are processed on the first worker and 4 of them on the second worker. Then we can stop the streaming and also stop sending messages. It takes a bit of time for the Spark streaming application to stop. And then we can retrieve the data here using a SQL context, reading from Cassandra, and see that the data was logged.